We'll work on problems 1, 3, 5, 9, and 10. I'm going to start with problem 1 first. We're going to copy it down on a separate sheet of paper. Label each equation A, B, and C so that they stay in your head correctly. Now that we've got our equations, we can just work with A and B first. Remember, our goal is to eliminate Z. So this means that on the A equation, I have a positive 1z, and on my Z equation down here, I have negative 5z. So if I multiply my top equation by 5, 5 times 1 is going to give me that 5z, and that will cancel. So I need to multiply this top equation by 5z, or by 5. So let's multiply by 5. There we go. I'm going to rewrite my A and B over here. 5 times 3x is 15x. 5 times negative y is negative 5y. 5 times z is 5z. And then 5 times negative 1 is negative 5. The next one, remember, you don't have to actually do anything to b down here because we kept it the same. The only one that we changed was a. So we're just going to copy down b. 3x plus 2y minus 5z is negative 16. When we add up these equations, you've got 18x, negative 3y, your z will go to 0, and you're left with negative 21. Okay, that takes care of A and B. Now let's go on to B and C. My B and C equations, I've got a negative 5z, and then for C, I've got 2z. So if I have a negative 5 on the top and a 2 on the bottom, I can multiply the top equation by 2, because 2 times negative 5 is negative 10. And I can multiply the bottom equation by 5, because 2 times 5 is 10. And that'll give me negative 10z and positive 10z, which will cancel. So I'm going to multiply B by 2. I'm going to multiply C by 5. B by 2 and C by 5. 2 times 3x is 6x. 4y, negative 10z, negative 32. And then if we multiply this line by 5, 5 times 3x is 15x, plus 15y, plus 10z is 30. Now we can add up these equations. 21x, 19y, the z's go to 0, and negative 2 is what we're left with. Now let's take just our linear equations, and we can solve these out. The first thing I'm going to do is solve this equation. I can pick either one to solve for either x or y, but I'm going to pick this one, and I'm going to solve it for y. So 18x minus 3y equals negative 21. I'm going to add 3y to both sides. Add 21 to both sides. I'll have 21 plus 18x equals, this will go to 0, this will go to 0. I'll have 3y on this side. And now all I need to do is divide by 3. 21 divided by 3 is 7, 18 divided by 3 is 6, and 3 divided by 3 is 1. So what I know is that y equals 7 plus 6x. I'm going to take this information, and this y are the same. So what I'm going to do is just match these up. This 7 plus 6x is going to go in here for the y. So 21x plus 19 times 7 plus 6x is going to be negative 2. Alright. So 21x plus, and then I'll distribute my 19. 19 times 7 is 133. 19 times 6 is 114. and then equals negative 2. 114 and 21 will get me to 135. And then I'm going to subtract this 133 here. Minus 133, like that. Dividing by 135, I get x equals negative 1. Now that I know that x equals negative 1, I can take that information and substitute it back into any one of my original linear equations. You know, these ones with the arrows? Any one of those I can substitute this back into. So I'm just going to substitute it here. If x is negative 1, then that's what this will be, negative 1. So 7 plus 6 times negative 1 equals y. 7 minus 6 equals y. So y equals 1. Now that I know my x and y's, I can come back up here to any one of my original equations and get my z value. So I'm going to choose A. 3x minus y plus z is negative 1. So I'll have 3x plus negative y plus z is negative 1. 3 times negative 1 minus 1 plus z is negative 1. Negative 3 minus 1 plus z is negative 1. So z equals 3. So on this one, my final answer will be the coordinate triple, negative 1, positive 1, positive 3. And that'll take care of our answer on number 1. Let's move on to number 3. Alright, so now we're working on our 3 equations for number 3. I've labeled them A, B, and C, and I'm ready just to work with equation A and B first. Let's eliminate our z variable. If I multiply A by negative 4, negative 4 times negative 1 will give me a positive 4, and a positive 4 with a negative 4 will cancel. That's going to happen in the future, so what we want to do is just multiply this entire equation A by negative 4, and we're going to keep B the same because it already has the negative 4 that we need. So x times negative 4 is negative 4x, positive 4y, positive 4z is negative 20, and then 4x minus 4y minus 4z equals 15. When we add this up, that cancels to 0, that goes to 0, that goes to 0, 0 equals negative 5. Since this is a false statement, we can say that there is no solution. Okay, let's go on to number 5. So now we're seeing that they want me to correct the error. I can see in the worksheet that they have chosen this equation. If we multiply this equation by 3, 3 times 5 is 15, negative 3. Negative 3 times 5 is negative 15. Negative 3 times positive 3 is negative 9. Negative 3 times negative z is a positive 3z. And negative 3 times 15 will be negative 45. Then it looks like they just kept this line the exact same. So when I describe the error that they use solving this system, I can say that they did not distribute this correctly. This should be a positive 3 because, this should still be a negative 3, but what they did was did not multiply this correctly. So if you kept it a positive, though, positive 3 multiplied by a negative would give you negative 3z, and negative 3z would cancel with positive 3z. So unfortunately, they used the wrong number here. So we need to put that as our answer for number 5. Number 5, the student multiplied the first equation incorrectly. And we can even say what it should have been. If we multiply this top equation by a positive 3, that should give us 15x plus 9y plus 3z equals 45. And your C line, which they kept, is going to be the 3x minus 4y plus 3z equals 8. Your z's will cancel out to 0, and then you can add up your equation. So it should be 18x plus 5y equals 53. And what they got out of it was that negative 12 minus 13y equals 53. So multiple mistakes in here. Again, the real answer, they should have multiplied the top equation by positive 3, and you can tell that they multiplied it by negative 3, and that was where they made their mistake. All right, number 9 and 10 are the only two that we have left. Let's get started. All right, so again on this problem, we have our setup here, and we are looking for A and B to pair up, and we just want to cancel out our z variable here. So on the bottom, I have a positive 4z. On the top, I have a positive 2z. So if I multiply this by negative 2, negative 2 times positive 2 is going to give me a negative 4z, and that will cancel with this positive 4z because negative 4 and positive 4 goes to 0. So I need to multiply this whole equation by negative 2. So my A equation will be negative 2x minus 6y minus 4z is negative 10. My B equation will stay the same, 2x plus 6y plus 4z equals 10. That goes to 0, that goes to 0, that goes to 0, that goes to 0. So 0 equals 0. This is a true statement, which means we have infinitely many solutions. So in other words, when you are making your system, what happens is you drew your line. When you went to graph the other line, it was the exact same line that you found. So all of the coordinate points that they have in common are all of the coordinate points of the line. And this line goes on forever and ever and ever, which means infinity here, infinity here. So because all of the coordinate points, you have an infinite amount of coordinate points, there are infinitely many solutions. Let's go on. The very last one is number 10. Alright, so number 10 asks us to build our equations. Once we finish writing them, we're going to solve them like we did the other problems. So let's work with A, B, and C. The first thing our problem says, a nursery has 200 palm trees. They've got coconut palm trees, they've got saw palmetto palm trees, they've got Christmas palm trees. So I'm going to use N for the coconut, I'm going to use S for saw palmetto, and I'm going to use C for Christmas. And those will be my variables. We know that they've got, between the coconut, the saw, and the Christmas, they've got 200 of them. So that's your first equation. You're going to say the coconut, the saw palmetto, and the Christmas tree, all of them together, there are 200 of them. Okay, so now that takes out our first line. Our second line says coconut palm trees sell for $75 each. So $75 each for that one. For the saw palmetto, they are $45. For the Christmas, they are $30. So we can write that out as well. Because we know that when it comes to these dollar amounts, we know a total dollar amount too. So that's the other side of our equation. So we can say that, let's see, your coconut is $75 each. So $75 for the coconut tree, $45 for the saw palmetto, and $30 for the Christmas tree. And all together, it said in the problem, the total purchases was 12,300, and these are all in dollar amounts. That's our second equation. Now we just have these two sentences, the middle one and then this last one. So the nursery has 3 times as many saw palmetto. So saw palmetto. The nursery has 3 times as many saw palmetto as they do the Christmas tree palms. So this will be our very last equation. C equals 3s. Okay. So we can take out this sentence too, because now we have that equation, and that leaves us just with the last one. How many type of each palm tree does the developer purchase? All right, so our last equation was C equals 3s, which is good news for us. This means that we can take this information and substitute it into any one of our other equations. But the process is still going to be the same. We're going to take A and B, and then we're going to take B and C like that. Okay, so I have over on this side, I have a positive c and a positive 30c. So if I multiply this equation by negative 30, that's going to give me negative 30 and then positive 30, and that'll cancel. So I'm going to take this equation, multiply it by negative 30, and I will get, for A and B, I'll get negative 30n plus negative 30s plus negative 30c equals negative 600. My next equation can actually stay the same, 75n, 45s, 30c. Thankfully, this will cancel for us, is 12,300. So when we combine our equation, we've got the first variable is going to be 45n, and then this is going to be plus 15s. Again, this goes away to 0, and we're left with 11,700. Okay, now we've done A and B. Now we still need to do B and C. Let's tackle B and C. We know that C equals 3s, so that's what I'm going to do. Instead of multiplying this, I can actually just say, okay, if C equals 3s, I'm going to take this 3s and I'm going to substitute it in for C. When I do that, I will only have N and S, right? Because this one, this C over here, will also be an S. So I'll have N, S, S as my variables, and that's what I have over here, N and S. That's all I need to do. So I'm going to say B and C. C is going to come up here to B, so I have 75N plus 45S plus 30, and C is 3S, is 12,300. So we're going to have 75N. This 30 times 3 is 90. So 90 and 45. Like that. Now I've got my two equations, and I can solve them out at this time. Let's see here. I'm going to check and see if 11,700, if I can divide that by 15. And if I can, and it does, it divides cleanly, so I'm actually going to solve this equation for S, just to help me out here. So I'll take this equation down here. I'm going to have here 15S equals 11,700 minus 45N. So I'm going to subtract 45N from both sides, and that gets me to this number. Divide by 15, and I've got S equals 780 minus 3N. Now that I know this information, if I know what S equals, I'm just going to take it and substitute it right into my other equation S variable. So I'm going to have 75N plus 135, and instead of S, I get to write 780 minus 3N equals the 12,300. Again, from here, all I'm going to do is distribute 75N plus is 105,300 minus 405N equals 12,300. I can subtract 12,300. I can subtract 75N and add 405N. When I add everything up, this goes to 0, this goes to 0, and this goes to 0. 105,000 minus the 12,000 is going to give me 93,000. And over here, I've got 405 minus 75, and that gives me 330. And now I can divide by 330. And that gives me my final answer.